Stanford University.
Okay, welcome to Lecture 8, CS193P for fall of 2011. Today we are going to talk finally about the view controller lifecycle. We've been putting this off a little bit, lecture to lecture, but you haven't really needed it. Probably don't even need it for your homework assignment. In fact, you definitely don't. But there's some really convenient methods inside the view controller lifecycle to help you manage what's going on in your application. So you'll be happy to see this stuff. And then I'm going to kind of cover three somewhat powerful but simple to use views, the image view, the web view, and the scroll view. And I'll have a demo that, if we have enough time, I'll actually do two quick demos. First, I'll show you how the Dr. Pill's website controller, how we did a popover with it using a UI web view. And then I'll do a little image view, scroll view demo. If we don't get to that, I'll just do it at the beginning of the next lecture. So let's start with the view controller lifecycle. So when I say that view controllers have a life cycle, that just means, you know, they get created, they live, and then they die, right? And so what happens when they live? Well, when they live, as they go through their life, view controllers do certain predictable things. And as they do these predictable things, you get to find out by overriding methods in view controller, okay, in UI view controller, because you always have a custom subclass of UI view controller. That's your controller in an MVC. So you just override these methods to do this. And it, you know, you can be abused by overriding these methods and doing stuff, because sometimes you want to be doing them in other places like setters or getters and things like that. But you should also not feel like, you know, it's not allowed to override these. You definitely want to use them in a lot of situations. So the first part of the view controller life cycle is its creation. It gets created. And we've already covered all this. It's mostly done by a segue and a storyboard. That's what creates a view controller. Remember that a segue always creates a new view controller. There's no such thing as a segue that doesn't create a new view controller, right? In the split view, for example, when you're talking from your calculator to your graph view controller, you don't need a segue because it's already on screen, okay? Now, you could use a replace segue there, but that would create a new graph view controller, which, you know, the only problem with that is that little button replacement dance is kind of a pain in the neck. And it's really kind of unnecessary. But segues create new view controllers. Also, there's that method I talked to you about in Storyboard called instantiate view controller with identifier, where you just have a view controller laid out with its view laid out in a storyboard, and you give it an identifier, and then you use this method, and it'll instantiate one for you. And then it's your responsibility to put its view on screen, either by pushing it in a navigation controller, maybe putting it in a popover or whatever. Because of this, because of you know, these view controllers are coming out of storyboards, we almost never in iOS 5 override the designated initializer for a view controller. We sometimes do for a view. You remember in init with frame, occasionally, and we do that thing where we have awake from nib and init with frame. They're both common method for views. But we generally do not do that in view controller. The other reason we don't generally do it is because there's so many other methods for us to override to put the code where we want. So, as you'll see. Awake from nib, we saw that in the demo that we did last time. It does get called in view controllers. It's sometimes a good place to put it. It's very early in the life cycle, right? So this view controller has come out of a storyboard. So awake from nib means it came out of a storyboard. And it's in its split view controller, let's say, but its outlets aren't connected, okay? So you kind of want to stay away from awake from nib. The view controller is really not in a fully constructed state. But there's some things like setting that split view delegate that you want to do early. Right, really early. And since we know that in awake from nib it's in a split view controller by then, we can do it there. So what are some of these other methods that happened? Well, the number one method is view.didLoad. So view.didLoad is sent to your UI view controller when it's fully instantiated and all its outlets are hooked up. So your controller is completely ready to go. It's not on screen yet, okay, but it's ready to go. So view.didLoad is really where you're going to put most stuff that you're thinking would go in a designated initializer override. Most of it's going to go in view.didLoad. Okay? The one thing to be careful about view.didLoad, though, is that the size of your controller's view, okay? Let's remember that controllers have a property called view, and that view points to the top level rectangular area of your view, the thing that you're editing in the storyboard, that top level. That view is just whatever size it was in the storyboard. Okay, it's not necessarily the final size it's going to be, because it might be in a navigation controller, it's going to get squinched down a little bit to make room for the bar, or it's in a split view controller that's in landscape, and so it's going to kind of be more square than the portrait rectangular. You see what I'm saying? And that has not happened. That squishing or placement has not happened by view did load. So be careful in view did load, right, with geometry. If you do want to set something based on geometry, right, you want to lay something out, then the next one is a really good method. It's view will appear. Okay? So view will appear is sent to you just before your controller's view gets put on screen. So this is an awesome time if you want to make any last minute adjustments based on the view arrangement, the view geometry. Is a great place to do it, because your view has been now sized to wherever size it's going to be, and you can adjust some subviews if you want, or set some settings, or whatever. Another great thing you can do in view will appear is lazily do stuff. So remember we did lazy instantiation? That means we didn't instantiate the calculator brain or whatever until we actually needed it. We can do other lazy things here, where if this view never appears on screen because the user never clicks this button, or never this segue never happens, or whatever, then we're not going to waste our time doing something that's never going to matter. So view will appear is a good place to start off something that's expensive. All right? But you want to be a little careful. If it's something that's expensive in terms of time, it's going to take a long time to run. Well, you don't want to do it in view will appear. You probably want to start it off in another thread in view will appear, and then in your view have a little spinning wheel. Right? So you see this in iPhone apps. You click some button and the screen changes right away, but then there's a spinning wheel because it's loading something from the network or whatever. Usually what's happening there is in view will appear, they're firing off a thread to go do that network load and putting up the spinning wheel. And we're going to show how to do the spinning wheel a little later when we show you how to do threads. So view will appear is good for those two things, kind of last minute, lazily waiting to do something expensive, and also geometry things. There's also a view will disappear. So this is called just before your view goes off screen. Maybe someone hit back in the navigation controller and you went off screen. Or you are in a popover and the popover goes away. Okay? Now your view will disappear. So this is just before. You're still on screen right now. It's just about to disappear. So here's where you might remember the state of your view, like the positions of the scroll bars or some other thing that's going on in your view that you want to restore later. Like maybe you'll store it in NS user defaults and then restore it later. Okay? This is also where maybe you might store things to permanent data store. But I'm actually a fan of any time you change something in the UI, I'd fork off a thread, or if it's cheap to write, I'd store it. Okay? Users expect the phone to be instant switch. They're in the middle of typing something in and a phone call comes in, and they don't want what they type to be lost. Okay? So you don't want to think of it in terms of save. It's really not a save. There's no Command S on a phone, right? So I'm a big fan of write it out if you possibly can. Okay? You want to write it out on sensible boundaries, right? You don't want to be writing every character they type in a text field, but you know, anytime they click on another text field after having typed something or made a gesture that changed something, I'd try and write it out to permanent storage. Okay, that's what users are going to expect. But if there's something that fits in the category of I can't really do that, I need to know that the user's gone from this thing, then you can use view will disappear. There's also did versions of both view will appear and view will disappear, so you can find out just after, okay, you appeared on screen, right? So maybe you want to start some animation, right? View did appear, you want to start an animation that goes on screen or something like that. So you can do that too. Notice that in all of these view wills and view dids, you want to call super. Okay, so see where it says super view will disappear right there? So you would want to do that in view did load, view will appear, disappear, did disappear, all of them you want to call super. Whether you call it at the beginning, at the end, it's kind of up to you, right? If you're doing something that you might depend a little bit on what your superclass might do in view will appear, then you can do it after. But if you're doing something that you maybe want to be set up before your superclass would do its view will appear, then you can do it before. But you have to call the supers version in these methods, okay? Another nice thing in the life cycle is the frame has changed, okay? So this happens, for example, when you do auto rotation. The frame of your view changes, Okay, and we saw this, that we handled this mostly with struts and springs. But what if the struts and springs just aren't good enough, like your calculator's layout? There's no way you can do struts and springs and make your calculator lay out in landscape automatically. So the methods here, view will layout subviews and view did layout subviews, are called just before the subviews get laid out because of a frame change. Okay? And just after, just before and just after. So really in either one of those methods you can get involved. Like in the did, you could go and look at your calculator and just move all the buttons. You know, in view did layout subviews, now your bounds is the new size, so you can just run around and move all your buttons, you know, using some algorithm to lay them out nicely in the new bounds. Okay? If you want to know specifically about auto rotation, okay, this previous one is just general frame changes. If you want to know specifically about auto rotation, there's a whole bunch of will and did rotates as well. Okay? One thing about will and did rotate is if you've got an animation going on your screen, you know, a bunny bouncing on the screen or something like that, and the person rotates, you might want to stop the bunny bouncing, let the rotation happen, because it's going to do some animation to move slides and then when the animation finishes with the did rotate, then keep the bunny bouncing again. You see? So, something to think about. All right, this method, which in the past has been the bane of students in this class, called view did unload. This is the part of the life cycle where it's a low memory situation. This only happens in low memory situations. And the system is going to unload your view, meaning it's going to take your self.view, your controller's view, and throw it out of the heap. Stop having a strong pointer to it, basically. It's going to set its strong pointer to it to nil. Okay? Now, and then after it does that, you get called view did unload. Okay? Notice there's no view will unload. You only get called after your self.view has been set to nil. Now, why would you do anything here? Really, you could make the argument you don't need to do anything here, because all of your pointers into views that were in your self.view, all your outlets, are all weak. So as soon as that thing got thrown out of the heap, all your pointers are going to get set to nil. But there's kind of a best practice here, which is that in view did unload, you're going to set your outlets to nil anyway. Okay, and why would you do this? The only reason this would make any difference is if someone somewhere else had a strong pointer to one of your outlets. Okay, and then an unload happened, you would want to be in a consistent state where all your outlets were nil. Okay, because you know you were unloaded, you were cleared out of memory. By the way, the unloading never happens when you're on screen. Okay, no matter how low a memory situation is, it's not going to unload the view controller that's on screen. Okay, so your view controller is off screen somewhere. And your view controller itself is not being cleared from the heap, just its view, okay, to save memory. This rarely happens, by the way. So a good citizen here would set their outlets to nil just to be sure they're nil, even if someone else has a strong pointer to them, just to be in a consistent state. But if you don't do this, I'm not going to ding you on your homework. You can rely on that weak pointers thing, because you're usually not going to have such a complicated app that there's any chance you're going to have another strong pointer besides, you know, an outlet to a view. Okay? So I want to just briefly, because I know some people have asked about this. It used to be we didn't have storyboard. We had these things called zip files. And when you allocated and initted a view controller, what you did was you did this alloc init with nib name, and you specified this nib file that had your view in it. Okay, we don't do that anymore, but I just want to make it clear we don't do that anymore. Okay, I know this exists. Yes, it was NIOS 4. We don't do that. All right, storyboards now. The other thing is, it is possible to create a view controller without a storyboard or a zib. Okay, basically using alloc init to allocate and init the top level view and all the subviews of a view controller. Okay, we don't do that anymore primarily because of documentation. The storyboard is documentation of your user interface. All right, so you don't want to have part of your user interface being built with alloc inits, because someone looking at your storyboard is not going to see that view controller. So they're not going to be able to see kind of the flow of your UI. So the way you do it is you override this method load view. Load view, that method has one job and one job only, to set self.view. Okay? Normally you never set self.view. In fact, I'm going to tell you right now, do not ever say self.view equals anything in a view controller except inside load view. which you will not have to implement for this class. So in this class, you can say, never say self.view equals, all right? You do not, and what's more, you don't want to implement this load view if you're using a storyboard. Okay, it's kind of undefined behavior to be using a storyboard to create a view controller, and also it implements load view. That makes no sense. Load view is only for view controllers that are not being instantiated, not from storyboards, which is a really rare case. So this whole slide is kind of rare stuff that mostly old. We don't really do it anymore. Okay, but note the red things there if you do decide you're going to do this load view thing at some point. Awake from nib, I already said, avoid it if possible. It's an acceptable place to do it, early initialization, but view did load is a lot better place to put stuff, okay? Because all your outlets are set, you're kind of ready to rock. So try to stick with view did load. All right, one last thing, and this is about the frames of your views. So this is an important question for you to understand the answer to. Who's responsible for setting the frame of a UI view? And the answer is, it's the object that puts that view into the view hierarchy. Okay? Now normally, who is that? It's the storyboard. You're dragging the views out and moving the little handles, right? To resize them, you're setting the frames. Okay, all's good. But if you do alloc init, alloc init with frame, what frame do you pass? And the answer is, it depends on whether you're going to put it right into the view hierarchy. It says in interface builder, but now in Xcode. So the frame that's passed to init with frame, if you're just creating the thing but you're not going to put it into a view hierarchy, you can pass almost any frame, although I recommend against CG-rect 0, in other words, passing a 0-size frame, because the struts and springs won't get into any kind of normalized state if it's 0, 0. Okay? It needs to have some size so that the struts and springs know what edges they're connecting to. You see what I'm saying? So that when it gets larger, when someone does put it into a view hierarchy, it's strange. So you can pass anything you want. Specifically, setting frames in view did load. If you're calling alloc init with frame to create a view, which usually you won't because usually your views are created in storyboards, but if you are, it really probably doesn't matter too much what frame you specify in view did load, except for that whatever frame that is wants to make sense relative to all the other frames that are already in there. But again, view did load is not the final geometry. So usually what you want to do is pick a frame that makes the thing fit in whatever the geometry is in view did load, but set your struts and springs right so that when view will appear happens, the thing will get stretched and struts and springed to make it look good. Okay? Now this is not a big deal because you're not usually doing alloc init with frame. Okay? But some people want to do that, and for some reason they feel like they can't just drag something out in storyboard. And in iOS 4, it wasn't quite as robust. There weren't quite as many things you could drag out from the story. But now in iOS 5, we almost never do this. OK. Any questions about the view controller lifecycle? No? Good. It's very straightforward. All right, UI image view. So UI image view is a super simple class. Okay? It's a UI view, subclass UI view. And it just displays a UI image. Now, I already talked about how to make a UI image back in lecture 4, so I'm not going to go over that again. Here's how you set the UI image. Again, you probably set it in the storyboard, right? In the storyboard, there's in the inspector, boom, set image, bam. But sometimes the image might be controlled at runtime, in which case there's this property called image on the UI image view. You just say image equals some UI image instance, simple as that. Of course, you can alloc init with an image as well, but be careful, there's a difference here. When you alloc init with an image, the frame of your UI image view will be set to the size of the image. Okay? The bounds, size, and width will be the same. But when you set the image with using the property, it doesn't adjust the frame. Okay? So if you want, when you set an image, if you want the UI image view to resize itself to match that, you have to explicitly do it yourself. We'll see that in the demo. Remember UI view's content mode property? You need this for your homework. This is the thing where we set the face view so that its content mode was redraw. So when the face view changed size, it would redraw itself to be more high resolution. You want this for your graph as well. The content mode also specifies how an UI image is drawn inside a UI image view. Okay? Does it scale it? Does it scale it and try to keep the aspect ratio the same? Does it just keep it in the upper left-hand corner? What does it do? Okay, so the content mode, you set that to control that. There's a bunch, well, not a bunch. There's only a few other features inside of UI image view. Specifically, a UI image view can have a highlighted version of itself, and then a property to set that, which one you're using. And then it also can do a sequence of images. So do an animation. You can control the animation rate and things like that, which is kind of fun, all right, if you have some kind of sequenced animation. So that's it for image view. Very, very simple. UI web view, also super simple, and yet it's a full internet browser in a view. So it's a subclass UI view that gives you a full internet browser. All things that you can do in Safari, you can do in this view. It's quite remarkable. It's built on this platform called WebKit, which is something I believe Apple started, or at least they proselytized. But it is an open source HTML rendering framework. I think it's used on other phones that shall remain nameless. It supports JavaScript. It'll only run for 5 seconds, though, so you can't like lock your phone down running some infinite JavaScript loop thing. And also, it'll only allow you to JavaScript to allocate 10 megabytes of memory, so that it doesn't push all your apps out of memory on the phone. There's a very important property that you're almost always going to want to set, which is scale pages to fit. That says whether the website is going to get zoomed down to fit inside your UI web view. If not, it's going to be its natural size, and not only that, you won't be able to scroll around in it. So you almost never want this to be no, and yet it's the default. In iOS 5, you can actually get the scroll view rather, that the web view is using to scroll around inside itself by using this property. And so you could actually have the scale pages to fit equals no, and then get this property and turn the scrolling back on and do that. But you can control how the scrolling is happening inside your web view using this property. You load up the HTML. You have one of these 3 methods to do it. You can either just give it some HTML as a string, right? Something you have embedded in your app. Just give it the HTML and it'll show the HTML. You can ask it to load data. Okay, a certain MIME type like PDFs and things like that. It's actually, WebView is quite useful, not just as a web browser, but to show certain data types like PDF. Okay, if you have a PDF file and you want to show it, you would use a UI WebView probably to do it. There's also a quick look framework for doing that. We're not going to cover that, but just so you know it exists. But the number one way to load HTML is the first one, load request. Okay, NSURL request. We'll talk about that in a moment. For these other 2, the base URL is just the URL from which all relative URLs inside the HTML are relative to. And the MIME type says how to interpret the passed-in data, because the passed-in data, you can see, is just an NS data. You got to know what type is in there, and the MIME types specify that. But NSURL request is the main way to do it. Why is it an NSURL request instead of just NSURL? And you can see that there's a way to take an NSURL and turn it into an NSURL request using the NSURL request class. And the difference between just doing an NSURL and having an NSURL request is that you can specify the caching policy, like don't get this page from the internet, only take it out of a local cache, or use caches that have expired instead of checking the freshness of the cache. Only use validated caches, all that stuff. You can specify that stuff. If you don't specify that, you get reasonable defaults. A URL, an NSURL, is very, very much like an NS string almost, except for it's well-formed. So it's like file:// and then a file system path, or HTTP:// some HTTP path out there. And so if you try to create a URL with a string and it's not well-formed, you'll get back probably nil. So that's it. But otherwise, NSURL is very much like NSString. When we start working with files, which we will next week or the week after, we're generally going to, we can use NS strings to specify file names, but we're generally going to use NSURLs, right? URLs are more generic specifiers of resources than strings. Okay. And the last one I'm going to talk about here is scroll view. Now, scroll view, a little more complicated here, and there's a little more to talk about, so try to get through here. One thing I'm going to show you first is a little demo of how powerful scroll view is, because scroll view, all I'm going to show you how to do is scroll around in a too big area, too big to fit on screen, so I want to scroll around in it and zoom in and out. But actually, scroll views can be embedded inside other scroll views to make quite sophisticated UI. So watch this demo. Right, here we go. Okay, so that's normal scrolling, but that's just vertical scroll bars inside horizontal. And then here's another one where we've got a horizontal scrolling, and yet we can vertical scroll once we get to one. See what's happening there? All right, so you can use scroll views, inside scroll views. It's very powerful objects, one of the most powerful objects in all of iOS. I couldn't possibly show you all the things that it can do today. So I'm just going to show you the basic way to get it working, and then you can go check its API out in the documentation to see how to do much more sophisticated stuff. Okay, so here's my demo. Here's a quick review. How do we add a subview to a normal UI view, not a scroll view? Well, we just set the subview's frame, or we did it in Storyboard, and we call add subview, right? If we didn't put in Storyboard. So here I got that Stanford logo. I just set its frame to that upper right-hand corner, and I said add subview. But what if I have a view that's, or thing that I want to put in there that's just too big to fit, right? Like I have this picture of Stanford campus. This is probably a UI image view, let's say. You know, if I tried to add this as a subview, it's going to look like that, okay? That's obviously no good. So this is what UI scroll view is for. All right, so what's it look like to add subviews to UI scroll view? Because UI scroll view, you also just add subviews to get things to show inside of it, all right? Instead of just saying set the frame and do add subview, first you set the scroll view's content size property, okay? So this content size is just a big size, all right? And it makes an area that the scroll view is going to scroll around in, okay? So I've moved the phone here to show that it's going to show a window on this area. And then when you do add subview on a scroll view, it adds it, it uses the frame of the view to put it in this area, okay? So here I've added that Stanford logo by going to, that's probably not right, but let's try this one. So here, add the Stanford thing here. It's at 50, 100, right? 50 in, 100 down, and it's 2,500 wide, 1,600 high. But the whole content size is 3,000 by 2,000, right? So that's how it places there. So basically, when you add subviews to the scroll view, it's putting them in this little content area using the frames of the subview. Everyone understand what's happening here? So we're putting them in there, and then once we put them in there, now we can scroll around in them, right? And as we scroll around, we get to see what's in that content area. Now, normally, this would be a bad situation that I've shown right here because we have areas in the content size of the scroll view that aren't covered. Those white areas, that's not good. So normally, we would move these subviews, like the Stanford logo, and then the Stanford campus, and then we'd make the content size shrink to fit the biggest one of them, right? So now, when we're scrolling around, we're not seeing any of the white stuff in the background, right? We can still see the Stanford logo there. So that's how it works. It's as simple as that. You create that content size, you add subviews, they go in there, and it just scrolls around in it, okay? Now, how do we know where it is? We'd like to know where the scroll view is currently showing. Well, one way we can find out is by getting the upper left-hand corner of the visible area. So this upper left-hand corner is the property called content offset in scroll view, and it's just the X and Y of the upper left-hand corner, and this is in the content area's coordinate system, right? So X and Y. So in this case, you know, that's probably, this thing's what, 1,600 high. So that's, you know, maybe 500 is the Y and the X is maybe 900 or something like that, right? That's where this thing is. And as it moves around, this content offset property is just constantly changing. You can always ask where it is. Another way to do it would be to look at the scroll view's bounds. That's the yellow area right there. It's important to know when you're trying to figure out what is the scroll view's bounds? What is the size and width that the scroll view is displaying? You just look at the scroll view's bounds. You might need this for your next week's homework, okay, to know what the scroll view's bounds is. But you might want to convert that, for example, to the Stanford campus image view's bounds, or coordinate system, because they're different coordinate systems, right? The scroll view's bounds is its own coordinate system, and then the Stanford campus is in the content areas. So you can do that using this standard view method called convert rect to view. And what that'll do is give you the same rect, the scroll view bounds, but in the content area's coordinate system. Okay? One thing that this next assignment you're going to be asked to do is going to make you do is think about coordinate systems. Okay? You got views and subviews. You've got all the subviews of a scroll view that are in this content area. I'm going to make you think about whose coordinate system am I talking about. And the one thing you want to be very careful is to always be in the same coordinate system whenever you're doing any mathematics. Okay? If you're doing any calculations, you got to get both parts of your equation in the same coordinate system, either both in the scroll views or both in the content areas. Okay? Fair warning there. So how do you create a scroll view? You can allocate it with frame it. It's just a normal view, and then just set the content area and start adding subviews. It works great. But of course, we usually get them out of storyboards. And how do we put them in a storyboard? We select a view that we want to be scrollable, and if we go to the editor menu in Xcode, there's an embed. Remember, there was embed in navigation controller for view controllers. There's also an embed in scroll view for views. So you say embed in scroll view, and boop, it'll put a scroll view around your view. Simple as that. So if you do alloc init, though, or even if you do it in the storyboard, you might want to add subviews programmatically to it, and you simply do that with add subview, right? It's pretty much what we saw on the previous slides. So the frame of the thing you're adding is relative to the content area's coordinate system, which is 0, 0 in the upper left, and content size.width and content size.height. Don't forget to set the content size. This is a common mistake, especially you do embed in scroll view, and you're going to see your image there, and you're like, oh, I'm ready to go. But no, you have to set the content size to be big so that you're scrolling over it. If you don't, by default, the scroll view is going to have a content size which is just its bounds, as big as its bounds, so it's not going to scroll anywhere. So don't forget to set the content size. That's the main thing that makes the scroll view go, is specifying how big an area you want to scroll over. Okay, you can scroll programmatically by doing scroll rect to visible. So here you're specifying a rectangle in the content area's coordinate system, and it will make that visible. Okay, it'll do the minimum amount of scrolling necessary to make it visible. Mostly the user is scrolling by touches, right? They're doing panning, but you can do it programmatically too if you want to, for some reason, show them, start off something, scroll to a certain spot. There's a ton of other stuff you can do in control view. Like I say, you can control whether scrolling is enabled at a given time. You can control the locking. Like remember when you had the scroll views inside scroll views, it would know whether you're doing horizontal or vertical scrolling by your first few pixels that you move, and then it locks so that you're not doing diagonal scrolling, right? Because we had a horizontal scroll view inside vertical scroll view and vice versa. So it'll do locking. You can control the style of the scroll indicators. One thing you should do is call this method flash scroll indicators in your view did appear. Okay? Because you just want to let the user know, hey, you can scroll here. All right? Another thing you want to do with scrolling, it's a really good idea to have not an even number of things fit in the scrollable area. So if you had a table, a list of items, you would want half an item cut off at the bottom. Okay, design the height of your item so that one's half cut off. It's a real simple way to tell the user there's more items down here. If it's exactly right on the even boundary, then they think, oh, there's only these 7 items, that's all there. They may not think there's a scroll bar there. And there's also mechanisms, really more sophisticated mechanisms for doing content inset, like the content part might be inset from the content area. You have to look at all that stuff in the doc. All right, but the other main thing that we can do in scroll view besides panning around in this big content area is zooming in and out on it, okay? So zooming requires you to do a few things, okay? And one thing about zooming is all it's doing is setting the transform property on your UI view. So all UI views have this transform property. But the transform property is not what you might think. Okay? It's an affine transform. Okay? I don't know if you guys have taken graphics, but that's basically just, it's got scale and translate and rotate. Okay? Those are the 3 things in this transform. But when you set the transform of view, you're affecting its bits. Okay? So imagine you got your view, it's drawing on screen, but it's actually drawing off screen into some buffer and then copying the bits, the pixels, onto the screen. Well, when you set the affine transform and you scale it, it scales the bits up. It doesn't redraw your view bigger. Okay, that's why we do that content mode redraw thing unused, because we don't want that behavior. If you rotate it, it's rotating the bits. If you translate it, it's translating the bits. Okay, so this is just bit movement. So normally we don't do that because that's usually not what we want, is the bits being, maybe we want that for translate and possibly for rotate too, but for scale we often don't want that. But understand that that's what UI scroll view is doing when it zooms, is scaling the bits, because it's just setting this property. That's all it does. You can also only zoom on one view in your content area. You can't zoom the whole thing. Of course, if you want to zoom the whole thing, easy. Just make a UI view that covers the whole space and put all your other views as subviews of it. It'll work great. But you specify a specific view inside your content area to zoom. Now, how do you make zooming work? There's some things if you don't do, it's just not going to work. It's not going to zoom at all. One thing you have to do is set the minimum and maximum zoom scale. Okay? So 0.5, setting the min zoom scale to 0.5 means that you won't allow it to zoom more than half its normal size. And then setting the max 1 to 2 means you won't be allowed to zoom up more than twice its normal size. The default for these two is 1, which means no zooming. Okay? So you must set that. Number 2, you have to have a delegate. Okay? You have to set the scroll view's delegate, otherwise it will not zoom. And that's because you have to implement this delegate method called view for zooming in scroll view. It returns which view in the scroll view subview list you want to zoom. Okay? Which one you want it to go set that transform to be scaled. Make sense? So that's all you need to do, but you got to remember to do those things. Set the delegate, implement that method, and set the min and max. If you don't do those things, and believe me, you will forget to do one of them on your homework, and you'll be like, what the, why doesn't this work? This is why, okay? You're not doing one of these things. Now, once you have those things working, then you can programmatically zoom, okay? And you do that by either setting the zoom scale directly, like if you want it twice as big, set it to 2. And you can do it with, there's a version that animates the change, which you would want to do if you're on screen. And then you can also zoom to rect. And now, zoom to rect, I'm going to show you with an image because it's a little easier to see that way. So this is zoom scale. So see that little gargoyle or whatever is a little big. If I set the zoom scale down to 1, he gets small. If I set it back to 1.2, he gets 20% bigger. So that's setting the zoom scale. And then here's the zoom to rect. So let's say I specify this rect. So I'm going to call zoom to rect with this little white rectangle. Watch what will happen. Okay? It zooms that rectangle, the minimum amount to fit inside the scroll view. And what if the rectangle were big, like this, bigger, and I said zoom to that rect? Well, then it would shrink it, the minimum amount, to fit on screen. Okay? So that's what zoom to rect does. So that's how you can programmatically, in your code, zoom in and out. All right, so UI scroll view has lots and lots of delegate methods. I'm not going to cover any of them except for view for zooming in scroll view, but there are things like scroll view did end zooming with view at scale, okay? And it's going to tell you, I'm finished, the user was zooming and his fingers went up and this is where I ended up. This is a good method, for example, where if you don't want to have that affine transform bit zooming, here you might redraw your view, okay, using your draw rect by saying set needs display or whatever. But when you do this and you're going to redraw, make sure you set your identity, your transform back to the identity one, because otherwise it'll be confused because the transform is going to be scaled up or scaled down, and you're going to be redrawing it. It's going to scale the bits up and down. You want to stop doing that if you're redrawing, okay? So anyway, all the other delegates are, you know, scroll view did do that, will do this, should do that. Yeah, take a look at them. Okay, so demos. So I have 2 demos to do today. One is I'm going to show you how I put that Dr. Pill's website. I don't know if you all looked at that, downloaded any of that psychologist code, but I'm going to show you that code. Super simple, and I'll show you how that popover segue worked while I'm at it. And then I'm going to create a new app called Imaginarium, and Imaginarium is just going to be a UI image view embedded inside a UI scroll view. And we're going to enable zooming, so we'll do the delegate dance and all that stuff for that, okay? All right, so let's go over here to Xcode. And I'm going to keep doing this live on the iPad here. All right, so let's go back to psychologists. So this is the psychologist that I posted on the web that had the Dr. Pill's website, which is this thing over here. So let's just run this to remind ourselves what this does. All right, so here we are. We went to Dr. Pill. I'm going to press on I have a serious problem. Dr. Pill is sending me off to Dr. Pill's website, which I changed. Dr. Pill is now sending you to Google. It loads up a little faster than my little website. So you can see that it presents the pop-up, the Dr. Pill's website here, inside of a pop-up. Right? So this is Google, and this is live. I could search for something in here, pill or something. And etc. Okay? I'm not going to do it because I don't know what would come up. So that's that. So okay, that's a reminder how it works. So how do we make that work? How do we do that thing? So let's go look here. All I did to make that work was I created this segue right here. Let's zoom in a little. Okay, so I created this segue. I just control dragged from this button over to this new view controller that I made. Okay? And it made this segue. Here's the segue. And let's look at that segue and see what it said. All right? So here's my Dr. Pill website view controller, which we'll look at the code for in a second. So this segue, I didn't even need an identifier because I don't do any preparation for the segue. That Dr. Pill website view controller only goes to Google. Okay? It doesn't go to anywhere else. But if I wanted it to go somewhere else, like I wanted it to be a configurable website view controller, then I would have to identify this segue, and then in the prepare for segue, I would just set some public property in Dr. Pill website view controller or generic website view controller to set the place I wanted to go. But in this case, it's built into Dr. Pill website view controller. And you can see that it's of style popover, right? And here's the directions that I'm going to allow the little arrow in the popover to point. This anchor is the thing that the little arrow is going to try and point to, which is obviously the button, the Go to Dr. Phil's website button that is right over here that I segued from, right, this little guy. And then you can even specify the pass-through views here. Remember, those are the views that if I click on them outside of the popover won't go away. Because normally I click outside the popover, it dismisses itself. Okay? So it's as simple as that. Doing popover segues is the easiest segue, right up there with push in terms of ease. Now let's look at this guy right here. Make some more space. So this is my UI. This is my Dr. Pill website view controller. And all I did here was I dragged out a generic view controller, okay, and then I inspected its identity, which let's select it, and I'll show you that. So I selected its identity and changed it from generic UI view controller, which is what it was at down here at the bottom somewhere, right down here. It was that, and I changed it instead to be Dr. Pill website view controller, which is a custom subclass of UI view controller that I created. Then I dragged out a UI web view. So that's down here. Well, UI web view is right here. See, right there. I just drag that out and put it in here, just like we drag out a custom view or like we dragged out our face view, etc. I dragged it out here, and then in Dr. Pill's website view controller, I created an outlet called Web View, which I will show you here. I'm just right-clicking on it there to see that. And you can see that that's right here. See, as I mouse over it, hopefully you can see the blue highlighting there. I connected it up to that. So that's all I did in the storyboard is dragged out a generic thing, change this class to be UI Web View instead, or sorry, to be Dr. Pill website view controller, then dragged out the web view, connected the outlet to it. That's it. Okay? Now let's go look at Dr. Pill website controller. I put this in this bonus folder down here. So it's just a UI view controller. It has this property, that web view. Okay, I synthesize it. And then in view will appear. So here we're seeing us using a view controller lifecycle method. Okay, I just do two things. I set that scale pages to fit that I told you almost always want to set. And then I create a URL request. Okay, by creating a URL using the string Google. Okay, and then I send the message load request to the web view, and it loads it up. And that's it. I also made should auto rotate be yes. Because it's in a popover, it can be in any orientation. Any question about that? Super simple. I mean, web view, very powerful, very easy to wire up, and popover segues also very easy, very powerful mechanisms, okay? All right, so that's it. That's all I was going to show you on that. Next, let's talk about the image view and scroll view. So I'm going to create a new project here, and a single view application as we always create. I'm going to call it Imaginarium. We'll have the class prefix also be that. And let's go ahead and make this one universal. We've been making them all iPhone, but we're going to make this one universal just to see if there's anything different, and there is something slightly different. So I hit next. Wants to know where I want to put it. I always put it in my home directory developer with the other things that we've done so far. And it creates it. Here's our project settings, etc. So I'm going to go straight to my iPad. I'm only going to build the iPad version of this because I got an iPad here, and you could imagine building the same thing on the iPhone side. It would be exactly the same. So let's go ahead and see what it's created for us using that template. And you can see that it gave us just a blank view controller, but it set its class to be Imaginarium view controller, right? Because I set that class prefix to be Imaginarium view controller. And in fact, here is our Imaginarium view controller. And you can see that it's put in stubs here for the view lifecycle, the view controller lifecycle. You see them? And also I'm going to point out this little interesting difference. And it does this when you make a universal app. It creates the should auto rotate to user interface or to interface orientation a little differently. Okay? What it says is if I'm on the phone, then I'm not going to allow portrait upside down. Otherwise, I'll allow anything. Okay? Which is kind of strange. I'm not sure why they don't like portrait upside down on the phone. Also notice that they check the idiom a little differently than I said in the slides. I told you to use that macro, UI underbar interface, underbar idiom or whatever. They're actually calling the method user interface idiom on the current device. Okay, so this is a perfectly fine way to do it as well. The thing about the macro, it was designed so that you could have the same code that would even build under like iOS 3, where this method didn't even exist. But you don't really care about that because you're going to be building your code under iOS 5 anyway. So this is just a little different way to do that idiom check. Okay, and we'll just leave it that way. It doesn't really hurt us. Okay, let's go ahead and get started here. Well, I'm going to do a very simple starting part of my iPad here. I'm just going to drag an image in, drag an image view in, set its image, and then we're going to run. Okay, no scroll view at the start. So the way we do that is we just bring up our object library down here, and I'm going to go down and get an image view. It's right here. Okay, see that? Displays a single image or an animation sequence. So I'm going to drag this in here. I have to zoom in. You've probably learned by now that you can't drag things into your view controllers unless they are full size, right? So I'm going to do that. So let's get this bit, put this here, put that in here. I'm going to make it so that it goes all the way to the edges. I'm going to check my struts and springs. It might be a good idea to get in the habit of every time you drag a view out, just check its struts and springs. Okay? So this is set to stick to the edges, which turns out to be exactly what I want. So that's good. And now I want to set this view's image. So I just go to the inspector, and you can see that there's an attribute here for image view called image, as you might expect. But there's nothing in the list. Okay? So how do I get an image to put in here? And the answer is you drag it in to your project. All right? So I happen to have a image. Let's go to my pictures. I've got this one right here. And we're going to drag this in here. I'm going to do the thing here where I copy the items in so I don't have a pointer over to that thing. And if that thing changes, I lose it. So I'll go do that. So now I have this Giants thing. It's been loaded into my resources of my application. And so now if I go to my storyboard and click on the image view and I go to image, you can see that it's in the list. Okay? Now I could set the image of this image view in code, using set image, but it's nice since here I'm going to have a fixed image in this thing to go ahead and set it right here. Now, you'll notice also that it has scaled this image. Okay? It automatically scaled it. In fact, it didn't even maintain its aspect ratio. Why did it do that? Well, that's because of the content mode. So you see here, this view right here, view content mode. If you select a view, oh, and one other thing I'm going to show here is start using this document outline. So we've really ignored this document outline right here. I think from the very first in the walkthrough I said, just leave this closed, don't worry about it. But I'm going to try and use it a lot in today's demo because it's a great way, especially if you have views embedded inside other views, to make sure you're picking the right view when you control, drag, or click on things, etc. So this document shows all the views in your view controller. So I have my top level view, right? That's the whole view. And then I have my image view inside of it. So it's really easy to select it. And if you see the attributes over here, this is indeed my image view. So if I don't want this scale to fit, I don't want AT&T Park here to get squished up and stuff like that. So I'm just going to change this to be, let's say, top left. Okay? And when you change it to top left, you get the top left corner. Now this is a big image, so I only get to see that little corner, which is not so nice. But that's why we need a scroll view. But let's go ahead and run this and see what happens. Okay, so here's my view. My struts and springs are working. That's great. But I can only see the upper left-hand corner. I can't zoom in on it. I can't move it. It's just static image. Okay, but it is nicely displaying the upper left corner. I think that's the upper left corner. Okay, so now scroll view time. So this is really why we set this up. We want to put this thing in a scroll view. So how do we do that? Okay, very simply, we select the image view. Let me make this full screen. We select the image view right here, and we just go up to the editor menu, and we say embed in, and if it's a view that you have selected, you'll have either you can embed it in another generic view if you want to group things, or into a scroll view, which is what we want. So I hit scroll view, it embedded it. Notice on the document history over here, now I have my top level view, then the scroll view, and then added as a sub view of the scroll view, the image view. Okay, so that's a good start. One thing, I just added a view though, so let's check the struts and springs. Okay, well now, this scroll view struts and springs are not really what I want, because the scroll view is sticking to the upper left. Really, I want the same kind of struts and springs I had with the image view. I want my scroll view to always fill the whole screen. Okay, so that's something to always check. So let's go ahead and run this, see what this looks like. All right, so here we have the upper left-hand corner, and scrolling not working. Okay, so we embedded in a scroll view, no scroll view not working. Why is that not working? Okay, so this is one of, again, the things that people are like, what's happening? Scroll view has to have its content size set. This scroll view does not know how big an area to scroll over. Just because it happens to have one subview that's very large, it doesn't automatically go and make itself large enough to do that. Okay? So you have to specify how big a space. So we're going to have to go write a couple lines of code. One, to set the content area of this, and two, to set the frame of this image view so that it's in the right spot inside that content area. So let's go do that. To do that, we're going to need to be able to talk to the scroll view and the image view from our view controller. So we need to have some outlets. So let's do that to start. I'm going to bring up the assistant editor here. We'll get rid of that. Let's go to our .m. We can close this to make some space. We can leave that up, move that over. All right, so here's our view controller. And I'm not sure why I'm missing that, but we don't need some of these things. Let's get rid of some of this stuff. Actually, let's get rid of all of it, and we'll put it back as we need it. We'll keep the rotation stuff. So to add outlets, I'm going to make them private outlets. So let's start by putting Imaginarium view controller private interface, right? So there's a private interface. And this thing got left up because I want to show here that you can control drag from these as well. So if I want to create an outlet to my image view, I can actually control drag from here over to there, okay, to create an outlet. So this is to my image view. It can kind of verify that that's what it is right there. I'm going to call this one image view. And then let's do the same thing. I'm going to control drag from the scroll view over here. Oops, missed. Sorry. Control drag. And this is the scroll view, which is good. Scroll view. All right, so I have outlets there. Now notice that it's automatically created the synthesize, just like it did in your walkthrough. And it also created view did unload. Remember I told you about view did unload? This is the low memory thing where it sets all your outlets. So it automatically does that for you if you control drag to create them. Why this doesn't use dot notation, I have no idea. Okay, I've never been able to figure out. It never has used it in all the history of iOS, and I'm really not sure why they didn't change that for iOS 5. But if I were doing this manually, I would say self.imageView equals nil. I wouldn't do self.setImageView colon nil. But there you go. All right, so now I have it. So now I'm going to use, let's say, view did load, which is really kind of the first place we want to think about putting stuff. And I'm always going to do super view did load. And so all I need to do here is set my scroll view's content size to be the size of that image. So where am I going to get that? From self.imageview.image.size. All right? So by the time view did load is called, both my scroll view and my image view, those outlets have been set up. And so I can ask them anything I want to get this place set up. Now, this is actually probably enough to make this work because we set our content mode of the image view to be upper left. So its frame is already upper left corner in that sense. But the size of our image view is probably now only the size of the scroll view. We want to set its frame to be the full size. So I'm going to say self, and I'm going to make this so we can see this. Let's go like this, sorry. And we'll go over here, make this wide. So I'm going to say self.imageview.frame equals cgrectMake. Okay, cgrectMake is going to be your friend. It's how you make a rectangle, right? cgrectMake. And I'm going to put it at 0, 0, upper left corner of my content area, my scroll view's content area. And I'm going to have its width be this width of the image. Okay, everyone understand that line of code? So I'm just setting the frame, which is where in the content area of the scroll view that the image view is going to live. I'm setting it to be the entire content area. Oh, did I miss height? Oh, good. Good call. Height. Okay? It's good. You guys, bonus points, even though, again, I don't know who said that. Bonus points to you for catching typing mistakes. So anyway, yes, width and height. Okay, everyone understand this code? Make sense? So now when we run this, it should work. All right, well, let's go to the simulator then, shall we? Good timing there. All right, so we'll run this on the simulator. All right, so here's our simulator. And now we can scroll around. Okay? Go all the way to the edge of the content area. Scroll around. But unfortunately, we can't zoom. See, I'm trying to zoom. I'd really love to see that Coke bottle a little closer there, but can't zoom. Okay? Why can't we zoom? Well, we haven't done the things you have to do to make it zoom. Set the min and max zoom scale. Set the delegate, implement that view for zooming and scroll view, okay? So let's go back and do that. Okay, so let's do the first of those things, which is to set the zoom scale. All right, so that's in scroll view. Let's get our thing. So here I'm just inspecting the scroll view. And let's see, attribute inspector. And you see in the attribute inspector, there's things like whether the scrolling is enabled and whether we do that direction lock thing, whether we do the bouncing. You know what the bouncing is, right? If you scroll too far, whether does it bounce off the edge, which looks kind of cool, or is it kind of, stop on the edge? So here's the min and max zoom. Okay, now I can set this in code too. It's just properties, but I'm going to set it here. So I'm going to make it 1/5 of the size up to 5 times the size. Okay, that's how much zooming I'm going to allow here. And now all we have to do is set the delegate and implement that method. So we're going to do that back here in our imaginary view controller. So the first thing we have to do when we implement a delegate is say that we implement that delegate. So I'm going to do UI scroll view delegate. That says my imaginary view controller is a scroll view delegate. Now all the methods in scroll view delegate protocol, all of them are optional. All right, so there's no warning. You see, it doesn't say, something not implemented or whatever. They're all optional. But if we want zooming to work, one of them's not optional, okay? And that's this method, UI view, view for zooming in scroll view. And all we need to do here is return which subview inside the content area we want to zoom. Well, we only have one subview here, so this is an easy one, self.imageView. And it is mostly the case that you're only scrolling over one view. I mean, you might have a view that itself has subviews, that's fine, but generally you have one view that's kind of the thing you're scrolling over. So it's not difficult to implement this method usually. And the only last thing we have left here is to set ourselves as the delegate. And this is a step that people forget often is, oh, I got to set myself as a delegate. Now, there's 2 ways to do it. We can actually do it in the storyboard, or we can do it in code. Okay, I'm going to do it in code right here in view.did_load. I'm going to say self.scrollView.delegate equals self. Okay? Why do I do it in code versus doing the storyboard? I think it's a little more obvious that we're acting as the delegate when we set it here in the code, especially since we're setting other scroll view things like the content size here. I think it's a little clearer, but I'm going to show you how to do it in the storyboard too, because some people argue every line of code that you put in your code is just another line someone has to read and understand what the heck it's there for, right? Whereas if you put things in the storyboard and you wire things up, then you don't have that line of code. All right, so let's go ahead and go back to our storyboard. And this I'm going to do entirely in the document outline. Okay, so I'm in this document outline right here. I'm holding down Control, dragging from the scroll view to my controller. Okay. Let go, it says, oh, what outlet would you like to set of your scroll view? And like, delegate, boom. Okay, so this document history thing on the left actually super useful for wiring things up and all that stuff, and you'll get quite used to it. Also, you can right-click over here and see what things are hooked up. I can right-click on my controller, for example, and see all of its connections. This is quite a useful spot in your UI. I didn't show you at the beginning just because I didn't want you to get too confused about the view hierarchy here, but now that you know about view hierarchy and you know about your view controller and all the things you can put in it, it's time for you to think about using the document history. All right, so let's see if I forgot anything. All right, so here we are. Can still scroll around. Let's see if I can zoom. Woo, there we go. 1/5 the size. Or, ooh, look at that grass. Beautiful grass. They really keep the grass in good shape at AT&T Park. Nobody there though. Okay? Okay, so that's it. So scroll view and image view, super easy to use, okay? The only thing about the scroll view is it's easy to forget to do one of those things like not set the delegate or not implement that view for zooming and scroll view, since it's always pretty much the top view in the content area anyway, so you'll forget to do it. Or to not set the min and max zoom size, that's another common one to forget. But otherwise, pretty straightforward to implement this stuff, and I have finished early today, so that'll make up for the few times I went over. If you have any questions, I'll be here.
For more, please visit us at stanford.edu.